Okay, so now we're looking at the binomial theorem. This is what the binomial theorem says. If you want to take a plus b to the n, that is n choose 0, a to the n. So you start also with a to the n, you subtract 1, b must pick it up because the power on those must be an n. But they use factors. If you write n choose 0, well, we know n choose 0 is 1. We just did it up there, right? 6 choose 0. N choose 0 turns out to be 1. N choose 1, that's n factorial over 1 factorial, n minus 1 factorial. N over 2 factorial, n minus 2 factorial. So it's kind of a big mess, it looks like, but there is a trick to it. That is, if you start with the powers, if you start with a to the n minus 1, b must pick up the 1, n minus 2, b must pick up the 2. The number in front of this will be n factorial, 2 factorial, n minus 1 factorial, as you see. So, instead of me trying to memorize this, there's a much quicker way I could apply the binomial theorem, and that is, I could say, look, this is going to be the x cubed plus the x squared 2 to the 1, the x to the 1, 2 squared, and the 2 cubed. And the way it's going to work, this is a 1 and this is a 1. Here it's going to be 3 factorial divided by 2 factorial, 1 factorial. And you know that this is 2 choose 3 or 1 choose, I'm sorry, backwards. 3 choose 2 or 3 choose 1 turns out to be the same thing. Here, this is going to be always n factorial over 1 factorial, 2 factorial. So this is x cubed plus, this is 3 times 2 factorial. That's 3 times 2x squared is 6x squared plus, this is 3 times 2 factorial. Those cancel out. That's 3 times 4, 12x plus 8. There it is. So using the binomial might seems to be a bit messier, but if you keep on looking at this in the sense of, oh, I see why that's happening. We're going to look at this in the sense of we want certain terms. We don't want the whole thing. So if we're going to use the whole thing, Pascal or this will do. Here it's going to be 2x raised to the 5th power. Then it's going to be 2x raised to the 4th power. That means the negative 1/3 will pick up the 1. 2x to the 3rd power. That means negative 1/3 will pick up the 2. 2x to the 2nd power. That means negative 1/3 will pick up the 3. 2x to the 1 power. That means negative 1/3 will pick up the 4. And negative 1/3 to the 5th power. Now in front of those, 5 factorial over 4 factorial, 1 factorial. 5 factorial over 3 factorial, 2 factorial. 5 factorial over 2 factorial, 3 factorial. 5 factorial over 1 factorial, 4 factorial. And this is a 1, we know that. So that is 32x to the 5th plus, this is 5 times 4 factorial. That's 5 times 2, 4, 8, 16, 80. That's negative 80 over 3x to the 4th. This is 3 times 2, I'm sorry. This is 5 times 4 times 3 factorial. Those cancel out. 2 divides 2 times, that's 10. 10 times 2, that's 10 times 8, that's 80 over 9 x cubed. This term, 5 times 4 times 3 factorial, those cancel out. That's also a 10. 10 times 4 is 40. That is 40 divided by 27x squared. This term, that's 5 times 4 factorial. 5 times 2 is 10. That's a positive 10 divided by 3 to the 4th is 81x minus 1 over 243. So a bit lengthy, but that's how it works if you want to use the binomial. We're not going to go that high on those. Now, this is where it all applies. We want to take an expansion and find specific terms. So find the indicated term or terms in the expansion of the given binomial. Okay, much better. I couldn't figure out why they're gone. So here they are. The first three terms of the expansion, well, isn't the first term 2x to the 20? The next term will be 2x to the 19. That means the negative 1/3 will be raised to the 1. And wouldn't that be 2x raised to the 18? That means the negative 1/3 will be raised to the second power. So this is a 1. This is 20 factorial divided by 19 factorial, 1 factorial. Now we're switching those, but since it's multiplied, it doesn't matter. They're the same. 20 factorial over 18 factorial, 2 factorial. Now on a test, this is all I want. For the homework, you're going to say 2 to the 20th. You have a calculator. 2 raised to the 20th. 1048, 576. 1048, 576. X to the 20 plus, isn't this 20 times 19 factorial? Isn't that 20 times 2 to the 9, so it's minus 20 times 2 to the 19th times negative 1/3, so over 3. What's 20 times 2 to the 19th? 20 times 2 raised to the 19th. 1048, 576, 0. 1048, 576, 0. Is that divisible by 3? Maybe, you never know. No, it's not. Okay. And that is x to the 19. And the next term is going to be, well, let's see. That's 20 times 19 times 18 factorial. The 18's cancel out. And 20 times 19 divided by 2, that's 10. That's 190. 190 times 190 times 2 to the 18. 190 times 2 raised to the 18. 498, 0, 498, 0, 7360, 7360, x to the 18. Again, this is a fine answer. There it is. Now, I could do that on my calculator one shot as well. But then I have to say 20 choose 19 times 2 to the 19th, right? To figure out this part. And this is how you do it. You would say 20 choose 19 times 2 raised, oops, and there's that number. Here, in the expansion, find the last three terms. Isn't the last term 2 to the 15th? The term before that, isn't that 2 to the 14th? That means you have a radical x raised to the 1. And the term before that, isn't that 2 to the 13th? And radical picks up the 2. Now comes the tough part, the coefficient. I know you think coefficient is the simple part. That's the hard part. Isn't this 15 factorial over 2 factorial, 13 factorial? Isn't this 15 factorial over 1 factorial, 14 factorial? And that's a 1. Wouldn't that be 15 times 14 times 13 factorial? 2 divides this 7 times. 15 times 7 times 2 to the 13. So again, on a test, that's all I want. But if you want to simplify it for that book, 15 What did I say it was? I lost track. 13 factorial 7. 15 times 7. 15 times 7 times 2 raised to the 13th. $860, $160, and when you square the radical you get an x. Plus, this will be a radical x, and I'm having 15 times 14 factorial. The 14 factorial cancel out. 15 times 2 to the 14th. 15 times 2, right? Okay, I keep on making that mistake. Raised to the 14. 245, 760. 245, 760. Radical x plus 2 to the 15th. 2 raised to the 15. 32768. 32768. And those are the last three terms. Now I look at the next problem. It says find the sixth term. Well, let's go this way. First term, second term, third term, fourth term, fifth term, sixth term is the one I want. Isn't the first xy to the 30th, to the 29, to the 28, to the 27, to the 26? Isn't the sixth term xy raised to the 25th? That means the negative 2, those must add up to 30. That must be to the 5th power. And isn't in front of this isn't that 30 factorial, 25 factorial, 5 factorial? See how quickly I could find a term? And in research, normally we're looking for specific terms. You want to plug that in a calculator, you can. Since you're using the calculator, you could say that is 30. Either you say choose 5 or choose 25, it doesn't matter, it's the same thing. So parentheses, 30, choose 25 times negative 2 raised to the 5th power. Negative 45, 60, 192, x to the 25, y to the 25. This is a fine answer for both. This is a fine answer for both. On a test, I suggest you leave it in the first form. How about D? Can you tell me the term that does not contain x? Well, for that to happen, I need the 3x and the negative 1 over x to have the same power, so they cancel out. Since that is 16, that should be the term, in which this is going to be x to the 8, and that's going to be 1 over x to the 8. The x to the 8's cancel out, which means in front of this is a 16 factorial over 8 factorial, 8 factorial. That's the term. You're done. You want to simplify? You can. Get a calculator out. Take 16, choose 8 times 3 raised to the 8th. That will be up. Oops, what happened? Eight, 444, 0070. That would be that term. How about the next one? The term containing b to the 8. Well, to get b to the 8, since b is raised to the 1/2, don't you want that raised to the 10th power? Actually, I'm going to change that. I want that to the 12 because I don't want you to figure out its half all the time. So, don't you want the radical b to be... Oh my god, that's not possible. There. To get a 6, don't you want to raise this to the 12th power because that's b to the 1/2? That means the 1 must be raised to what? What do you add to 12 to get 20? 8, which makes this 20 factorial over 8 factorial 12 factorial. That's the term. If you want to plug in a calculator, by all means, take 20, choose 8, or 20, choose 12. Same answer. 125,970, 125,970, b to the 6th power. So, very efficient for me to use the binomial theorem to find specific terms. How about those last two? Show that n choose n equal n. Well, let's see. That's n factorial over 1 factorial. What do you add to 1 to get n? Or subtract those two? N minus 1 factorial. Wouldn't you say the top is bigger than the bottom? So if I start reducing the top, isn't that n times n minus 1, and I could stop there because it matches the bottom? There it is. And n choose 0, well, that's n factorial over 0 factorial, and the difference of those, you have to use the definition here. That is n factorial, 0 factorial is 1, and n minus 0 is n factorial, and there it is. And if I want to apply that to this part B, let's see if how those could be the same. This is n factorial over k factorial, and the difference of those, n minus k factorial. This, oh, I messed up on that one. That's what I meant to write. Sorry. So, the right piece, I'll say, well, look, that is n factorial over n minus k factorial, and the difference of those, n minus k all factorial. This is n factorial over n minus k factorial, and if you distribute the negative, and isn't this and that exactly the same? So there it is. And that's the rest of this section.